This video is to help you review for Unit 6 quiz. So again, these will be the types of questions you should expect to see on the quiz. So the first one asks you to simplify using order of operations. Again, remember, even if they don't tell you to use order of operations, we should assume that you always should use that to get the correct answer. So first of all, order of operations tells us to work with parentheses. And we see that we have something inside parentheses here and something inside parentheses here. So we're going to go ahead and do that. So our next line would be 7 plus 4, and then in the parentheses, 5 minus 4 is 1, and 1 plus 1 is 2. And then in the other parentheses, 4 plus 3 is 7. Right? Now you'll notice that there is no operation sign between the 4 and the parentheses or the parentheses and the parentheses. So that means these are all being multiplied once we've done what's inside. So we're going to do that next, because multiplication comes before addition. So 4 times 2 is 8, and 8 times 7 is 56. Then our final answer would be 7 plus 56, which is 63. All right. Another one, what is an algebraic expression for the product of an unknown number and 3? So for an unknown number, you can use x, you can use n. Those are the most common variables that we use. But product of an unknown number and 3 would mean multiply. So 3 times n or 3 times x. You could make it n times 3 with using a raised dot. But again, the typical way we'd write it would be number in front of a letter without an operation sign in between, which means multiply. What is an algebraic expression for the sum of an unknown number and 6? So the word sum, of course, means answer to an addition problem. So if we're taking the sum of an unknown number, n and 6, it would just be n plus 6. Again, notice that these are asking for the expression, not an equation. You're not solving anything. You're just writing an expression, an algebraic expression, which is what that is. Then what is an algebraic expression for the difference of a number and 4? Difference means subtract. Now, when you subtract, the order matters. So since they have the number and then the 4 coming after, it needs to be n minus 4, not 4 minus n. If they had said, what is an algebraic expression for the difference of 4 and a number, 4 would have had to come first. So it'd have to be 4 minus n. But based on the order they put it, the number and 4 needs n minus 4. Same thing with quotient. Quotient order matters. So we are dividing, because that's the answer to the division problem with quotient. And it's going to be the unknown number and 2. So you might write it this way, or you might write it with the fraction bar. That would be the same thing. What you don't want to do, though, is, again, make it 2 divided by n, because that would be a different order than what they're saying. A square has a side length of x. What could be used to find the perimeter of the square? So we know that, of course, a square means all the sides are congruent. So how would we find the perimeter of a square? We'd add up all the x's. So you could have x plus x plus x plus x. You could have 2x plus 2x. Once you've simplified, you'd have 4x. A square has a side length of x. What could be used to find the area of a square? Well, for area, you're multiplying x times x. So it'd just be x times x, or x to the second power, x squared. Again, the reason that's called squared is because that's how we find the area of a square. We multiply a value times itself. So we call it squared. It's very logical, again, in terms of how we name things in mathematics. Evaluate the expression 3a minus cd for these values. All right. So 3a. Now remember, when you have a number next to a letter, it means multiply. So it's going to be 3 times the value of a, and they're telling us to use -4 for a. So 3 times -4 minus CD. Again, letter next to letter means multiply. So it's going to be 4 times 3. Again, common mistake is people want to make that 43, but that's not the case. This means letter next to letter means multiply those two values. So 4 times 3. So 3 times 4 is -12. minus 12. And this is subtraction, so we're going to use our keep change. So we'll leave our negative 12 alone, we'll keep it. We'll change our subtraction to addition, and we'll change our positive 12 to a negative 12. So negative 12 plus negative 12 gives us an answer of negative 24. There's quite a few steps in there that we have to be real careful about. Take your time and do it well. So again, pause the video if you need to, make sure that that makes sense to you. For the next part, you're going to evaluate that expression, x to the second power plus y to the second power, when x is negative 3 and y is negative 4. So it's going to be negative 3 to the second power plus negative 4 to the second power. Negative 3 to the second power would be negative 3 times negative 3, or positive 9. Oops. And, bad typing again. Negative 4 plus negative 4 would be negative 4 times negative 4 is positive 16. So a negative times a negative is positive. So negative 3 times negative 3 is positive 9. Negative 4 times negative 4 is positive 16. 9 plus 16 is 25. Then there'll be a second part to this where you will have to do it on pencil paper, and they're going to ask you to solve and graph. So if you look at this, this is an inequality. We know that because of this sign right here. If you have a less than or greater than, that means we have an inequality. So what we're going to want to do is to solve this and graph it. So the first concept is, how do we solve it? Well, we solve it as though this was an equal sign here. We want to get the x by itself, the variable by itself. So our first step is to subtract 2 from both sides. Again, the reason we're doing that is we are trying to get the variable by itself. The opposite of the positive 2 is to add a negative 2 or subtract 2. When you do that, this creates a 0 right there. So it zeroes out, which is what we want, and we get 3x. Our less than or equal to sign stays as is, and 8 minus 2 is 6. I want to make sure I bring down that less than or equal to part of it too. Okay. So now we know 3 times a number has to be less than or equal to 6. So the opposite operation to multiplying by 3 is dividing by 3. We show it in this way. And then we are going to have x less than or equal to, and 6 divided by 3 is 2. Okay. So when they ask you to solve it, this would be the solving part. X is less than or equal to 2. Then as far as the graphing goes, we are going to, on our number line, indicate the 2. And we want to show values that are less than or equal to that. Well, less than 2 would be values to the left. Equal to 2 would be values that land right on the 2, so it's a closed circle. So less than or equal to looks like this. Equal to part is right here. That's the closed circle. Less than is here. So this would be the solving. This would be the graphing. For the next one, same concept. We want to get the variable by itself. First thing we do is get rid of the minus 3. So we do that by adding 3. We use the inverse operation. So when we do that, I like to put the line down to show them what I get for the next part. The 4x comes down. The plus 3 and minus 3 zero out, which is what we want. That's why that won't be on that side anymore. And then what you do to one side of the equation, you had to do the other. So that's why I had to add 3 to the other side as well. And 10 plus that 3 is 13. So now we have 4x is greater than 13. Then we have 4x, but we want just x. So we divide by 4. Again, remember that the idea here is that that's creating a giant 1, which is giving us just x, which is what we're looking for. Giant 1 was up here as well. Okay, so we're getting x or 1x, which is what we want. And then if you divide by 4 on this side, you have to divide by 4 on this side. So whatever you do to one side of the equation, you have to do the other to keep them balanced and equal. So 13 divided by 4, you can put in your calculator, you could change it to a mixed number. Either way, you get 3 1/4 or 3.25. I would take either one. And then on your number line, you're going to mark your 3 1/4 or 3.25. Values that are greater than that are going to be this way. And since it does not have an equal sign here, this is going to be an open circle. What that means is that values greater than 3 1/4 are our solution. But if it lands exactly on 3 1/4, it's not part of the solution. So we indicate that with an open circle. All right. Another type, they want us to solve for x, show every step, and show the check of our answer. So the first thing we would do is combine any like terms that we could. So 3x minus 7 can't have anything combined. Those are not like terms. But on the other side of the equation, 6x and minus x can be combined. Those are alike. So 6x minus x would give us 5x. And plus 2 was going to be plus 2. So we're just going to bring that down. Now that is what we call combined like terms. So it is helpful if we write behind that what we did, which is that we combined our like terms. The next step is going to be that we want to get the variable on one side and the number on the other. So typically we would deal with the variable first, and it's nice to have that variable be positive. So we're going to subtract 3x from both sides. Again, the reasoning behind this is if you have 3 x's, the way to clear those out is to subtract them. And if you do it to one side, you have to do it to the other side. And when you do that, this is going to zero out, which is our goal. A common mistake is people bring down the 7, but they forget to bring down the negative sign in front of it. Remember, subtracting 7 is the same as a minus 7 or a negative 7. We need to bring down that negative sign as well. And then 5x minus 3x is 2x. And then we have plus 2. Okay, so we've brought down everything else. Then we now have x only on one side, which is, again, a big part of what we were looking to do. But now we need to get the variable only on one side. So we're going to get rid of the plus 2 to the other side. So again, how do we get rid of the plus 2? We take a minus 2 or subtract 2. So we're going to do that again to both sides. When you combine a negative 7 and a negative 2, you get a negative 9. And the 2x is going to come down. The minus 2 and plus 2 will zero out again. Our last step then is that we don't want to know what 2x is. We want to know what x is. So what we do is divide both sides by that coefficient. Divide both sides by the 2. Again, the purpose here is that this creates a giant 1. So we just get 1x or x, which is our goal. And negative 9 divided by 2, again, you can put that in your calculator or you can do it as a mixed number. You'd get either negative 4.5 or negative 4.5. Either answer would be fine. So you can write it as mixed number or you can write it as a decimal. Now, as far as showing the check goes, the check is something that you will be marked for. So you need to make sure that you're showing your check. Remember, the idea of a check is that it allows you to feel confident in your answer. And we do that in algebra often. So you're going to go to the original equation. And I like to just write it down again to make sure everybody's clear on where I got it from, but you would not have to. But I'm writing down that original equation, and this time I'm rewriting it with the variable being switched with what I think the answer is. In other words, I'm going to insert, instead of x, negative 4.5, because I have solved it, and I feel that x is negative 4.5, so I'm going to rewrite my equation replacing x with negative 4.5. Now the nice thing is at this point, you can use a calculator to do most of this part. But I do want to see that you did the rewrite. All right, now I will do this with some mental math because I should be able to. But you're certainly allowed to use a calculator. So 3 times negative 4.5 should be negative 13.5 minus 7. 6 times negative 4.5 should be negative 27. And then a negative times a negative 4.5 would be a positive 4.5. So on the left side, if I did a rewrite, and again, you don't have to because you would have a calculator, but if I did a rewrite, it would be a keep change change. So I would get negative 20.5. And on the right side, I would also get negative 20.5. So I will be looking to see that what you get on the left is what you get on the right and that it should be the correct value. All right. And then that shows that it checks. Now you might have gotten, depending upon the equation, depending upon the situation, you might get negative 5 equals negative 5, check. You might get negative 30 equals negative 30, check. There is something specific we'll be looking for here. But again, as long as the left side equals the right side and you've done it correctly, that will show that it checks, right? So this is your answer, this is your solving, and then this is showing your check. All right, so same concept here. We're going to solve and then show the check. Now, this time, it's not quite as elaborate as the last one because we don't have to combine any like terms. All right, that was our first step here on this one, remember. But here, there's no like terms on the left or on the right. So we're going to start by simply trying to get our variable to the same side. So I'm going to add a 4x to both sides. Again, why am I choosing to add the 4x instead of subtracting 2x? I could do it either way, but I prefer to have a positive variable. So then I'm going to get 65 equals 6x plus 80. That's because this is zeroing out. Okay, so then I want to get the x by itself, which means I need to subtract 80 from both sides. That's how I'm going to zero out my positive 80 to do a minus 80. All right, so 65 minus 80 is negative 15. And again, this is zeroing out, which was our goal. And then our last step is that we don't want to know what x is. We want to know what, we don't want to know what 6x is. We want to know what x is. So we're going to divide both sides by 6. Again, this is creating a giant 1. So, and you can put this in your calculator or you can make it into a mixed number. Again, I feel I should probably be able to do it in my head. Looks like 2.5 or 2.5. Negative 2.5, of course. So negative divided by positive is negative. Okay, then that would be my solution. Now I'm going to show my check. Again, for showing your check, you write the original equation. You replace the x with the value you found x to be, which I have found it to be negative 2.5. And if I've done something wrong, I should be able to tell at my check. So 65, a negative 4, and a negative 2.5 would be a positive 10. And over here, I'm going to get negative 5. So 75 equals 75, and that checks. Again, if you're not sure where I got these values from, the good news is at this stage you are allowed to use a calculator. But again, this equaling this shows that this was the correct solution. All right, another type. To solve the following, use the 5D process or solve it algebraically. So you're allowed to do either way, but you need to show all your work and show the check. So it says, I'm thinking of a number. When I subtract 6 from my number and multiply by 5, I get 25. What is my number? Now, at this stage in the game, I would probably do it algebraically, but you still need to define your variable. You're still going to need to show your work. You're still going to need to show your check. If you're going to also do the 5D instead, make sure you do your describe draw. Make sure you do your define as well as your do, your decide, declare should be part of either one. So, all right. So n is going to equal my number. When I subtract 6 from my number and multiply by 5, well, subtracting 6 from my number would look like this. And then it says, and multiply by 5. So that means that I'm going to take that whole thing and multiply by 5. It should equal 25. So when I subtract 6 from my number and multiply by 5, I get 25. What's my number? So I'm going to solve this algebraically, but again, you could do it with 5D. Just make sure you're showing all your steps or you won't get full point. All right, so the first thing I'm going to do here is use distributive property. So 5n minus 30 equals 25. Again, where that came from, well, first I'm going to put dp for distributive property, but where that came from is the 5 times n was my 5n, the 5 times the 6 was the 30. All right, now I'm going to go ahead and solve that. So I am going to add 30 to both sides. Oops, I'd like a different color for you. And again, what I do to one side, I have to do the other. So then I am going to get 5n equals 55 because this zeroed out. And then I'm going to divide both sides by 5. Again, this will create a giant 1, so I'll just get n, which is what I want. And n would equal, of course, 55 divided by 5 is 11. So 11 is my number. Now, if you had done it with the 5D process, again, make sure you write down your describe draw, make sure you write down your define, your do, your decide, your declare. So make sure you have the steps for that as well. All right, otherwise you won't get full points. But either way, we have to show all our work and we have to show our check. Okay, so showing our check, whether you did it with 5D or not, is still important. So I'm going to go ahead and put it into my equation. 5 times 11 minus 6 should equal 25. In other words, again, I'm just rewriting my equation. I probably should write that down above it. I'm writing down my equation and I'm replacing n with 11. Okay. So 11 minus 6, of course, is 5. And 5 times 5 equals 25. So it checks. So my declare, my answer is n equal to 11. That's my number. And this is my check. Again, with the next one, same thing. You can either use 5D or algebraically, but make sure you show all your work and make sure you show your check. Also, again, if you're going to do it 5D, make sure you're showing all of your steps. All right, because again, students tend to think that that might be a little bit easier, although again, I would argue it's probably not. But part of the reason I think is easier is because they end up not writing down all their steps and then they lose points. So it's important to make sure you have those steps. A school wants to sell t-shirts. Carla's shirts charge a one-time $70 setup fee. Each blank shirt costs $350. The total bill is $350. How many shirts were ordered? So again, you could do your describe draw. I'm going to do it algebraically, so I'm going to start with my define, where X is the number of t-shirts that were ordered. All right, so the key here is that first there's a $70 setup fee. In other words, just to come and do business with them, they're going to charge you the $70. All right. Sort of the same in any type of store. Like if you went to designer advertising or something too, they will charge you a setup fee to set up the design and so forth. And then after that, they'll charge you per shirt. So we've got this one-time $70 setup fee. And then we've got each blank shirt costing $3.50. So that means we pay $70 plus we're going to pay $3.50 times the number of t-shirts that are ordered. The number of t-shirts ordered times $3.50 plus that $70 setup fee is going to equal the total bill of $3.50. We're assuming we don't have to worry about tax or anything like that. So $70 for the setup fee plus $3.50 times the number of t-shirts has to equal the $3.50. All right, so again, if you're going to do 5D, make sure you're showing your process there as well. Now, if we're solving this algebraically, I am going to start by subtracting 70 from both sides. Because again, I want to get my x by itself. And then this is going to zero out. So I'm going to get $3.50 times x equaling $350 minus $70 would be $280. Then I am going to divide by $3.50 because, again, I don't want 350x. I want to know what 1x is. And the way to get that is to divide both sides by that coefficient, that number in front of the variable. I'm going to divide both sides by 350. All right, so when I do that, 350 divided by 350, of course, is just x, or 1x. And then 280 divided by 350, or $3.50, is 80. So x equals 80 t-shirts. All right, so that would be my solving. Again, I need to make sure, though, that I'm showing my check. So my check would be writing down that original equation, 70 plus 350 times x equals 350. Only I'm going to replace the x with what I think the correct answer is, which is 80. And then I'm going to be able to put the 350 times 80, $3.50 times 80, into my calculator, which is 280. And it looks like that will work because 350 will equal 350. That's my check. Oops, move this over a little bit out of the way. So that would be my showing my work, because I solved it algebraically. Again, make sure you show all your work if you do with 5D as well, including your 5Ds and your check. Additional problems that you'll have to do will be this type. Solve for x, show every step. So the first thing here would be that you would combine your like terms. So 4x minus x would be 3x. And we would put CLT behind that to say that we combine our like terms. Then we would get rid of our 3x from both sides because we want to get our variable to one side. So we're going to put a minus 3x and a minus 3x. And when we do that, this is going to zero out. And we're going to get 5. Oops, 5 equals negative 6. And this is going to zero out. Now, 5 does not equal negative 6. So when we get 5 equals negative 6, that should tell us something. It tells us that there is no solution because there is no situation in which 5 will equal negative 6. So we can write no solution this way, or remember, we can also write it with the circle and a dash through it, meaning it's an empty set. Can't happen. So that type of problem could be on there as well. All right, then for the next type, again, we're going to start by combining our like terms. So we've got 2x plus 18 equals negative 3x. Oops, I'm sorry, let me combine that. The negative 3x with the 5x will be 2x as well, plus 18. Again, that's combining like terms. So what I did is I combined my negative 3x with my 5x to get my 2x, and I combined my 16 with my 2 to get 18. All right, then I am going to subtract 2x from both sides. To get x by itself on one side. Or in this case, as you probably can already foresee, we're going to get x gone on both sides and get 18 equals 18. Now, as we know, 18 always equals 18. So remember, when we get that type of situation, we say infinite number of solutions. Meaning it doesn't matter what value we put in for x, everything would check. Now remember, you do not have to do a check for either of these types, all right? There's no way to do a check that would work for a no solution because nothing you put in place of x will have the left side equaling the right. There's no reason to do a check for an infinite number of solutions because no matter what you put in place of x, the left side will always equal the right. Okay, you could put in 1,000, you could put in negative 1/2, you could put in 0.2 repeating. The left side would always equal the right. So in both of these situations, you do not have to show a check. Infinite number of solutions or no solution. So again, those are the types of questions to expect to see. Please let me know if you have any questions.